Vibration analysis. Procedures for accurate evaluation of machinery condition. Common problems. Bent shaft. A bent shaft is a form of imbalance, and balancing can reduce the vibration level. However, balancing cannot straighten the shaft. The bent shaft prevents adequate alignment in some cases and causes clearance problems in others, depending on where the bend occurs. The characteristic spectrum of a bent shaft is a distinctive second harmonic, as in Figure 5. If the shaft is bent enough to cause a misalignment problem, one of the indications of misalignment could also be present. If a shaft is bent, the end of the shaft will rotate in an orbit. When this occurs, a force vector will be felt on the coupled shaft through 360 degrees of rotation. This force produces a high amplitude signal at the fundamental speed, as in Figure 3. For example, if a motor has a bent shaft and is coupled to a pump, the time signal and frequency spectra could be similar to Figure 5. The second harmonic is distinctive and is in phase with the fundamental. The frequency spectra and time signal from the pump indicate imbalance. However, the problem is caused by the bent shaft on the motor. The time signal is a good sinusoid. This is true because the shaft is bent by the same amount through 360 degrees of rotation. The only distortion would be that caused by the coupling, looseness, etc. If the second harmonic is not in phase or is changing phase with the fundamental, the unit is loose, and the shaft may not be bent. Where the unit is operating above first critical, there is a 180 degrees phase shift in the residual imbalance. Since the imbalance is caused by the bend in the shaft, the truncation could move to the top of the time signal in some cases, and the second harmonic would be 180 degrees out of phase with the fundamental. The section on coast-down data provides more insight. When troubleshooting, data should be taken in the horizontal, vertical, and axial directions. A bent shaft on a motor that belt drives another unit could look like imbalance, as in Figure 3, or the second harmonic could be present, as in Figure 5. As a simple test, insert a wooden pencil in the center hole at the end of the shaft. If the pencil vibrates, the shaft is bent. The VCI Model 340 proximity probe can also be used to measure the total indicated runout or TIR of the shaft while the machine is running. Thank you.